Today's lesson, Chapter 1, Lesson 2, using segments and congruence. In geometry, a rule that is accepted without proof is called a postulate or an axiom. A rule that can be proved is called a theorem. As you will see later, postulate 1 shows how to find the distance between 2 points on a line. First, we're going to go through some warm-up exercises to make sure we remember how to do these. So the first one, 3x plus 5 plus 2x minus 4. 3x plus 2x, we're going to combine like terms. It's 5x. 5 minus 4 is positive 1 equals 36. We're going to subtract 1 from both sides. We get 5x equals 35. So x equals 7. Now we want you to find 3 cities on this map that appear to be collinear. So if you look at this, it looks like I could draw a straight line between Chicago, Bloomington, and Springfield. So example number 1, we are going to apply the ruler postulate. Remember, a postulate is things we can accept as true. So if I were to measure the length of ST to the nearest tenth of a centimeter, mind you, this is blown up on my board. So if I actually took out the ruler, it may not work here. If you're looking in your book and you measure ST in your book, even if I start at 2, and go to here, it's 5.4, so 5.4 minus 2, because I started at 2, equals 3.4. The length of ST is about 3.4 centimeters. We generally accept that if we get a ruler, the ruler is correctly marked and measured. Hence, it's a ruler postulate. We don't have to prove that our ruler works. Along the lines of the ruler postulate is what we're going to talk about in postulate 2, segment addition, which means if I look at this line here, if I have line AC, then if I have line segment AC, the segments which make it up, which are AB and BC, added together will equal AC. In the beginning of this book, we deal with postulates that are very easy to understand so that you can start to see how this logic pattern builds. So in example 2, the cities shown on the map lie approximately in a straight line. Use the given distance to find the distance from Lubbock to St. Louis. Okay, now it's hard to see here, but Lubbock to St. Louis, that says 380 miles. And, Lubbock to Tulsa says 380. Tulsa to St. Louis says 360. It's hard to read that. It says 380. This says 360. When you add them together, you get 740. So it is fair to assume that from Lubbock to St. Louis is about 740 miles, and the most expedient way is to drive through Tulsa. So we're going to actually take the ruler, measure in your book. I'm not going to measure up here because this is distorted. But if you measure line segment MN in your book, it's about 1 5/8 inches. And line segment PQ in your book is 1 3/8 inches. And for exercises 3 and 4, we're going to use this diagram. So we're going to use the segment addition postulate to find the length of XZ. Well, we can see that XZ is a segment with point Y in between the X and the Z. So 23 plus 50 is 73. And in the diagram, WY is 30. can you use the segment addition postulate to find the distance between W and Z? Okay? And you cannot use the segment addition postulate because they're not on the same line. Yes, there are things in trigonometry that would allow you to eventually find that length, but we are at the very beginnings of geometry, and we are talking about using the segment addition postulate. In example 3, we're going to find a length. So we can see that F to H is a segment that is 36 units long. So 36 is going to be equal to 21 plus whatever GH is. So if I set this up like an equation, subtract 21 from both sides, I get 15 is equal to GH. Now I'm going to talk about congruent segments. Line segments that have the same length are called congruent segments. In the diagram below, you can say the length of line segment AB is equal to the length of segment CD, or you can say AB is congruent to CD. This symbol, and it's hard to see that symbol, it's the equal sign with a Spanish tilde above the top, means congruent. In this class, you will see that a number would be equal to a number. So if I would say 90 is equal to 45 plus 45, that's when I would use the term equal. But if I am talking about a segment, I would say here that AB, segment AB, is congruent to segment CD. These marks here show that it's congruent. If I drew a rectangle and I wanted to show that that side is congruent to that side, now these long sides are not congruent to the short sides, but they're congruent to each other. So I would put 2 marks there. The 2 marks with the 2 marks show that those are congruent. This and this shows that those are congruent to each other. Now we're going to compare segments for congruence. In this example, and they've done in the book, they had us plot these points in a coordinate plane. Then we're going to determine if JK and LM are congruent. So you can do all of this math here, where you can see that this is a straight line and it's plotted 1, 2, 3, 4, 5. So that's 5 units long. 1, 2, 3, 4, 5. This is 5 units long. They are congruent. Later in this chapter, we will learn how to use the distance formula to find this, especially if they are not straight, horizontal, or vertical lines. It's more of that problem. And now guided practice. 144 minus 37 is 107. For number 6, plot the points. So the best way to do this is to get a visual representation. A is here, is -2, 4. We're going to compare that to B, which is 3, 4. So the Y values are the same. The X is going from -2 to 3. AB is equal to 5 units. We're saying equal to because it's a number. CD, C is at 0, 2, and D is at 0, -2. So CD is 4 units long. We use equal because we're dealing with a number. So they are not congruent. We're already at the daily homework quiz. This is really a pretty short, simple lesson. So for problem number 1, AB to the nearest 1/8 of an inch, and they have the ruler drawing there, is 1 3/8. Number 2, C to E. CD is 7 units long, DE is 15 units long. You add them together and you get 22. Number 3, plot points, and we're going to see F and G and H and J are congruent. So F and G, well, I can see here that the Y values don't change. The X values go from -3 to 2. So FG is 5 units long. HJ, the X values don't change. From 1 to -3 is 4 units long. So they are not congruent because FG is 5 units and HJ is 4. For the next problem, find the length of KL. So we're going from -3 to 4. That is 7 units long. And now here are the problems that your homework comes from.